Hello friends, this video on D and F block elements part 1 is brought to you by examfear.com. No more fear from exam. The objective of this lesson is to learn the position of D and F block elements in the periodic table. We'll know the electronic configurations of this D block elements, also called transition elements, and F block elements, also called inner transition elements. We'll appreciate the stability of various oxidation states, and we'll try to understand the stability of various oxidation state in terms of standard electrode potential. We'll describe the preparation properties of important compounds like K2Cr2O7, KMnO4, potassium dichromate, potassium permanganate. We'll understand the characteristics of D and F block elements, and we'll also try to understand the general trend. We'll describe the properties of F block elements and try to give a comparative account of lanthanides and actinides. We'll try to compare these two series with respect to their electronic configuration, oxidation states, and chemical behavior. This is what we'll study in this chapter. So let's start the chapter. If you see this periodic table, this is the normal periodic table. This is pretty long. We want to squeeze it, so what we can do is this part, the one in the blue, we can put it down and we get this normal periodic table. This is a very long form periodic table. Little inconvenient because it occupies more space. So the part in the blue, the elements in the blue is squeezed down and you get this table. If you see, we have 57 atomic number here, and then from here you start here 58, and then similarly actinides 89, and then you have actinium 89, and then you have thallium 90. So this is how it is. There is a connection. Just to squeeze it, this part is down. Okay. Now if you see in this periodic table, we have this part was my D block and this part was my F block. D block is nothing but the block where the last electron enters the D orbital. F block is the one where the last electron enters F orbital. So based on the last electron entry, we classify the elements as S block where the last electron enters S orbital, P block where the last electron enters P orbital, D block where the last electron enters D orbital, F block where the last electron enters F orbital. So if you see the D block transition metals as per our design, these are my D block elements. Okay, also called transition metals. Please note these three are not called transition metals, but they are D block elements. Why? Because for transition metals, the definition is that it should have incomplete filled D orbital. We'll talk about that later, but just understand that these are not transition. Why? Because we talk about the electronic configuration of these, you will get D10. D is filled. If D is filled, they are not considered as transition metals. So if you see this D block element, there are a lot of metals like metals which we use: zinc, copper, nickel, iron, and a lot of precious metal like gold, platinum, silver. So it has a lot of metals which we use. In fact, we'll see that the valence electron is in 2 orbital. We'll see that. See in these S block and P block, we have seen that the valence electron is only in the S orbital or P orbital. But here you will see this is the energy difference between the D orbital and the penultimate orbital, that is an orbital before that D orbital, will be less. So the valence electron will be in these 2 orbitals. We'll understand that. So it shows variable oxidation state and they act as catalyst. So they have colored ions, they form complex, they have magnetic properties, they are hard, they have high melting boiling point. They are typically silvery, shiny, good conductor of heat and electricity. They are malleable and ductile also if you talk about zinc or any of the elements. And they are typically found in compound state because they are reactive. Few of them are found in the pure state also. Copper, silver, gold, copper, silver and gold, they are typically found in pure form. but others were actually found in compound form because they react with the atmospheric oxygen to form oxides. And few of them are very magnetic. For example, iron, cobalt, nickel are strongly magnetic. So we'll study all about these things in this chapter, right? Just understand that D block elements are nothing but my group 3 to group 12 is my D block. Okay, and this last electron enters this outermost D orbital. Okay, if we talk about the F block, this hole is my F block. And we have lanthanides, actinides, this is 4F and this is 5F. Actually, if you see, this is 4F and 5F. We will talk about this, lanthanides and actinides in details. So by definition, F block is nothing but the elements where the last electron enters outermost F orbital. Okay. So again, if you note that in this case, what is the group of these elements? So we see all these are taken from here, right? 57 to 58, now 89 to 90. All these are part of group 3. See, after this, there was no group increase. That means all these elements are part of group 3, and that is a little strange. So many elements only part of group 3. Okay, these are all part of group 3 elements. As I have told, these elements are my lanthanides from 58 to 71, and these elements from 90 to 103 are my actinide. See, there are two series of inner transition metals and they are called inner transition. Now the question comes is, why should we study D and F block elements? See, if you see all this development we see around us is because of iron. The big buildings you see, the big flyovers you see, it is all because of iron, right? So this iron and steel has changed our life a lot, and this iron is part of D block elements. Also, if you see the wires that is used, copper wires for transmitting electricity, is again the copper is a D block element. There are a lot of places where we use D block elements. The utensils in the kitchen is typically iron or steel. Steel is made out of iron. You must be knowing that, right? So these are all D block elements. If we talk about the alloys, brass and bronze, which has such a good properties, these alloys are also made from D block elements. Talk about battery. Battery has zinc, nickel, cadmium, and these are all D block elements. Zinc, nickel, cadmium. Coins. Typically, the coins are made of silver, gold, copper. These elements, I'm talking about silver, gold, copper, are all D block elements. D block elements are very good catalyst. We have seen nickel catalyst, hydrogenation. In Haber's process, we use iron catalyst. V2O5 is also used as catalyst. So they act as very good catalyst. There are so many reasons for that. They can have variable oxidation state. They are small in size. We'll talk about that. Understand that in industry, catalyst plays a major role. It saves a lot of money, and these D block elements are good catalysts. Nuclear reactor, a lot of F block elements and D block elements are actually used as nuclear fuel. Uranium, right? Thorium is also one more example. There are a lot of radioactive elements in these groups. In the photography industry, this is widely used. In photography, use light sensitive AGBR, silver bromide, and the silver is nothing but my D block element. So it has a lot of applications. There are a lot of applications of D and F block elements. Primarily the D block elements in the development. Iron, we know no development is possible without iron, right? So D block elements has so much application in our day-to-day life. It is good that we understand the properties and the trends of D and F block elements. As I told, we'll define what is transition metals. So the definition says the transition metal is one which has incomplete filled d orbital. Please note, it has incomplete filled d orbital in the ground state or any of its oxidation state. So the d orbital, as we all know, can have at the max 10 electrons. So the number of electron in d, if it is, can range from 1 to 10. So definition says if it is d1 to 9, it is a transition metal. If it is d10, it is not a transition metal. And when we are talking about the ground state or any of its oxidation state. So with these definition, my zinc, cadmium and mercury is not a transition metal, because zinc, cadmium and mercury, if you write the electronic configuration, actually I'll show you, it is d10. Talk about the zinc, it is 3d10 4s2. If you talk about the oxidation state, the common oxidation state of zinc is zinc 2 plus. In that case, the oxidation state is this. In both the case, the zinc has filled d orbital, and that's why zinc is not considered as transition metal. But if you talk about copper, the electronic configuration is 3d10 4s1. Will tell you why it is. If you see, this has filled d orbital, but if you talk about the common oxidation state of copper, that is 3Cu2 plus, this will have oxidation state of, electronic configuration of this. So if you see, it has 9 electron, it is half filled. So metals which has incompletely filled d orbital in the ground state or any of its oxidation state, right? Either ground state or any of its oxidation state, they are called transition metal. And with this definition, all these d blocks element except zinc, cadmium and mercury, they are regarded as transition metals, because in only these three metals or elements, the electronic configuration is always such way that the d orbitals are always filled, even in the ground state or in their common oxidation state. Okay.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.